I will now run ProgSim simulation on the strip assembly. First, I will define the simulation elements, starting with the OP boundary. Next, I'll define the pilots. And now the lower lifters. I will also enter the strokes for the lower lifter and the opposing pad in the upper. Then I will define the lower form tooling. The faces were automatically selected, but I will check to make sure there are no missing faces to be selected or extra faces that need to be removed. It looks fine, so I can click OK. I will also do this for the upper form tooling. Here I will need to remove some faces and also add others. I will also check that the trim tooling is correct. Next, I will add an upper pad for the first forming station by selecting the needed faces and entering the stroke. Then I will add another upper pad for the second forming station. The simulation elements are now defined, but before computing the simulation, I'll run the kinematics or motion of the tool elements to make sure that the elements are moving properly and in the correct distance. They look fine, and the simulation computation can be started. The computation is complete, and we can take a look at some of the analysis results, such as formability, also thickness, and max failure. Once satisfied with the simulation results, we can run Cut Optimizer to automatically develop the trim geometry. First, I will generate the target lines and enter the maximum deviation value. The target line geometry can also be modified. I will also verify that the target lines are chained with no gaps. And then I will start the simulation computation. Here we can see that there is a fairly large deviation between the simulated part geometry and the target lines shown in blue. Proxim will run multiple simulation iterations until the results are under the set maximum deviation value. It has started the second iteration, and we can see that the maximum deviation for the first iteration is 31 thousandths. The simulated geometry is now closer to matching the target lines. It has now started the third iteration, and we can see that the maximum deviation for the second iteration was 19 thousandths of an inch. So it went from a maximum deviation of 31 thousandths of an inch in the first iteration to a maximum deviation of 19 thousandths in the second iteration. Now the simulated geometry looks much closer to the target lines. The simulation has completed, and we can see that the maximum deviation in the third iteration is 8 thousandths of an inch, which is under the designated 10 thousandths of an inch maximum deviation. I will take a look at the results. The values are in millimeters. We can also see the results of the first iteration. I will now exit ProgSim and update the trim punches in the strip assembly with the developed trim geometry. I will begin by editing the sketch of the cutting punch, and then start the Optimize the Cutting Punch Outline tool. The optimized trim geometry is imported, and I click OK to accept it. The sketch entities are generated. I could make modifications, but I will exit the sketch now and repeat the process for any other trim punches that need developed geometry. All of the cutting punches are now updated with the developed trim geometry.